Hello everybody, I made this video because a lot of you requested in the comments of the previous video to add some steps or instructions on how to build a similar solar tracker. You can click on this link to watch the video and see what I'm talking about. Also guys, I never made a video on YouTube before and this is just to help some of you, so I hope you go easy on me. This project was created for educational purposes and demonstrations to students in order to have a first touch with solar trackers and photovoltaics. We wanted to create a dual axis system with both manual rotation of the panel and auto tracking of the sun. I will describe more on this later. Now I will briefly describe each step of this project. First step was the conception of the idea. We had two structures in mind and we designed both of them in ANSYS. In the end, we decided to go with the second one because the connection of the mechanical components was easier. In the end of this video, I will add a bad quality slideshow with highlights of the mechanical assembly in the factory. Now, the second step after the mechanical construction is done is the order of the electrical components. The main components are a 35-watt solar panel from Feazan, two 12-volt DC motors for the movement of the tracking system, but servo motors are also an option. From Arduino website, we ordered the board called Arduino Uno, motor driver L298 and LM2596. The motor driver is the intermediate component between Arduino and the DC motors. The motors are connected to the motor driver and the motor driver is connected to the Arduino, which controls the signal sent to the motors. LM is used to regulate the voltage. In this project, photovoltaic powers the solar tracker, which means no external source is used. The voltage from PV can exceed 12 volt depending on the solar radiation. The PV is connected first to LM, which gives constant output voltage of 12 volt to Arduino. If the PV is connected straight to Arduino, then in conditions with higher voltage than around 16 volt, we can burn the Arduino microcontroller. Other electrical components are 4 LDR sensors for sun tracking, 4 buttons, 2 switches, resistors and board. It's good to order more than what you need because some of them will be damaged. You can find the list with the components in the link in the description. It's time to explain the connection of the electrical components. Here I show how everything is connected and you can download the schematics of the electronics from the same link in the description. You just need to download the program called Freezing first, which is an open source CAD software for electronics. You can't see here the motor driver and the voltage regulator because they are not supported by this program. You can also use one breadboard instead of two. I just put second breadboard for the 4 LDR sensors above the photovoltaic, which is far away from the first breadboard. The way that the system works is the following. There is a remote control with an auto manual switch, single axis, dual axis switch and 4 buttons. While the first switch is turned to manual, you can manually rotate the panel using the 4 buttons, clockwise and anti-clockwise in horizontal and vertical axis. While the switch is turned to auto, we have auto tracking of the sun, single or dual axis depending on the second switch. For the tracking of the sun, the code and the operation is like this. For single axis, Arduino compares the average signal of the 2 top LDRs with the average of the 2 bottom LDRs and then sends signal to the horizontal motor through motor driver to rotate in the direction with the higher solar radiation. For the dual axis, the above loop is happening alongside the comparison of the average of the left and right LDRs. In the same link, you can find the Arduino code and use it as it is or adjust it to your own project. Thanks for watching and I hope it was helpful.